And welcome back to the Hamshack of KA4UPW. All right, continuing on with the IC7000 series. This week we are going to begin our first modification. That means we have to open the radio and do some soldering. Of course, that never fails when you're trying a video. Let's hope that doesn't continue to be a problem. To get into the top cover, which is all we need to access today, it's 3 screws on the top and 2 on each side. There might be one in the back I'll take a quick look for, but I don't think so. So we open the radio up. Get these screws out of here. Sometimes they hide one in the back, but not in this case. So that just leaves me with 2 more. Yeah, sorry about the hands in the way, but that's kind of the nature of videoing and working. Pretty simple. If you guys don't have yourself a little screwdriver set, these things come in really come in handy. Got several different ones, but yeah, this one was recently given to me. All right, we're about to take the cover off. Now, it's always good practice to put a wrist strap on. It's easy for you to say. Not so easy for me. So we're going to go ahead and put on my wrist strap. You know, down here in Florida, humidity is so high. This is not really that necessary, but it's always good practice, especially if you're up north, static areas. All right, so we have taken out all the screws. Now we're gonna, oops, did I miss? Yes, I missed one in the middle. Sorry about that. So let's, these ones on top. Okay, now we got the screws off. Carefully pull this away. You've got a speaker connection. We're not going to disrupt that. And what we're looking for is the DDS board. And the DDS board is this board right here. So we're going to remove that board by taking out these screws. And what I do is I take the back end of a little pair of tweezers, push it in here and give it a little twist to clear the parts. Before you pull the board, you're going to have to pull the fan out. 4 screws. Different length in these screws, so keep track of your screws, and pull this away, and this will allow us to access the DDS board. The modifications we're making today is going to be one for this fan speed, and that is a hybrid of what the fan mod by Cool as Ice author James Hammond KC4UPW has done. And the only difference I did was add an extra diode in there to help make sure that I'm not going to feed any voltage back, but we'll cover that as I'm doing it. The second modification we're going to do is add a couple of, I'm going to add a piece of capped on tape under the board above the cover. The side of the board we're going to be modifying will be, you know, with that will be on the underside, or literally what's called the top side. And we're going to put a piece of capped on tape in there because when this fan spins, it blows quite a bit of air under the board, and under there is my TCXO or my crystal and my divide-by circuits. So I'm going to put a little piece of Kapton so the air diverts around that, and we're going to put a little 3M pad, which I'll show you in a bit, on the crystal, and that'll keep what I want to do is, it's okay if these parts get warm, but what we don't want happening is a cold warm cycle, where every time the fan kicks on it gets cold, or it blows some cold air in, those things cool down a bit, and yeah, the temperature is going to shift on you a couple of hertz. So these are nice mods to do, just to kind of divert the fan around that critical part here and put a little insulated pad on that crystal, and so that to help with those transitions. Otherwise, you might get yeah, a little of that crystal drift might be just enough to disrupt your digital contacts. I have gone back to the cell phone. Much better. We're going to identify the DDS unit. This is on the top. You're going to remove the top cover. I've already got you there. And we're going to put a foam insulating pad on X1. Now this is not a, don't use a, you know, like a heat conductor pad. We want to do the exact opposite. I want to insulate it. So what I've done is got some of this 3M foam tape, and I've cut a little piece off and we've put it on here. The other thing we're going to do is IC301 is under a shield, and we are going to put a little piece of Kapton tape across that shield to ground so that the air flowing this way, where's my thumb, so that the air flowing this way doesn't blow across the crystal, nor does it blow across this. We want those to stay at a constant temperature. Warm is good, but a warm-cold cycle not so good. So we're just going to stop that little bit of airflow. That's going to help us stabilize the frequency a little bit. Doesn't take much. So here you can see the board where I've added the Kapton tape, and we'll get you some better, get you another view. And then if you can look way under here, see the little piece of 3M tape? That's your crystal. And that's the modification that we're going to do for temperature stability. So part of this next modification is we're going to run that fan a little bit longer and harder to cool everything down, which is another reason we don't want excess airflow. So we're going to locate pin number 3 on the, this is the auto tuner, right? I just pulled it up out of there. So pin number 3 is red. I'm kind of follow along here. We got yellow, orange, red. Pin number 3 actually ends up, we got yellow, orange, red. We're going to tack a 150 ohm resistor right here. Let me do that, and then I'll get back with you. And I have prepared the resistor by putting a little loop on there. That's going to aid me when it's time to place that. I don't know if I can get that to focus, but you can see where we're going with this right here. And that's going to take both hands and a magnifying glass, so I'll be right back. Okay, one more look before I solder this. I'm going to put this little resistor right on that pad. You can see how close that is. But we'll tack that down, and then I'll come back. Alrighty, that came out okay. I think I can get you a view of that. Magnifying glass here. We've got that resistor tacked on right next to that little diode. That's 12 volts. I used 150 ohms, and now we're going to tie this into the red. Hold on. Into the red of the fan motor here. So this one right here. Let me get a little further along, and then I'll snap another video. But you're basically, we're coming from right here and back over to over here. Alrighty, quick change on the fly here. See if I can zoom in on that. There you go. So that's our resistor. Focus you. Focus. Focus. And that's the diode that's sitting next to it from the original circuit. I'm going to follow the manufacturers here and do the same. Alright, so I'm going to use in this case, a 1N4002. So that's going to be 100 volt PIV, which is fine, and 1 amp. More than enough power. And we're going to add that right here so that the voltage I have can flow out of this. My guys, struggle is real here. I'm going to add this diode right here, band up. So that's going to allow the voltage to come up out of the connector through this and to my fan, but it's not going to let any voltage from the fan circuitry to come back to J1. And I think that's just going to be a little bit safer way of doing it. I'm going to get an extra 0.7 volt drop across there, but it should still be fine. There we go. That wasn't so hard. And let's continue. I sure hope I can piece all these videos together. So here I am tied into the fan. I get my red wire running back to my resistor and my diode. Now just a couple little things to tidy up and we'll be set to go. Alright, let's do that again. This time with the thing oriented correctly. So there's me tying into the fan. Follow that guy around, and there's my resistor and diode. I just got a couple of things to tidy up, and we'll be done with these two modifications. I'll be right back. Alright, I'll come in with a little bit of heat shrink. I put what's called as liquid electrical tape right here. Letting that dry. Alright, finally I can do this and video at the same time. We're going to protect this whole thing with just a little bit of 5-minute epoxy. Alright, got a nice little bit of epoxy there. I added a little more right on top for a little strain relief so these two wires ride together. A little more right there. So we're going to let this seal dry up, and then this thing will be ready to put back together. So I really should just voice this over, but this is fine. And here's some more view as I start to put this thing back together. The liquid glue is still not dry, but I've got the screws back in, and we're ready to start getting that fan back into place. Alright, everything kind of buttoned up, wires dressed back in. Only thing I'm missing, I guess, is I gotta get this thing back on, the little rubber pad, and we're good to go. Alright, let's get all the screws back in. Alright, and as we wrap up this video, this week's video, remember the end result is us wanting to get to a IF tap. So next week I'm going to be going over some of the powering, how I'm going to power. This is, this is where it gets you modify for your needs. How I'm going to power the Raspberry Pi, my radio, and my accessories that we're going to use for the digital modes. So I would like you in the comments to tell me what kind of SDR you plan on using. If you've already purchased it, you've used it, or if this is going to be new to you. Also, if you're already using SDR software, which kind are you using? You know, it's HP SDR, SDR Play, SDR++, lots of different versions out there. So please comment to which one you're thinking of using. And then finally, and this one's kind of important, is the platform you're going to be doing it on. There's Raspberry Pi 4 is a good option because it's got a built-in sound card. Raspberry Pi 5 is a great option. No sound card, we'll cover that. But you will gain NVMe capability for a better drive, faster drive. It's got a lot more memory. It's a very fast processor, but it's power hungry, and we'll discuss that as well. And then finally, if you've got a Linux machine around, let's just say an old x88 laptop or something that you've loaded Linux on, tell me if you're using Linux, and then or Windows 10 or 11 as well. I'm going to focus this series on Raspberry Pi, but you guys can use any computer and software that you're familiar with and already have running, as probably as well as any SDR. So, but in the comments, please let me know so that I can kind of tailor these next couple of videos a bit towards the kind of computer you're using. That's Raspberry Pi 4, 5, Linux, or Windows, and what software that you might already be using. Because I'm going to assume that you're going to adapt pretty much what you already know into this project. That's the fun of ham radio, is we get to do that, make it our own, and yeah, we'll wrap this one up. You guys have a great rest of your week, and we'll see you next week.